everyone, I hope you are doing good. So today we will take a new DSA question here, construct a tree from in-order and pre-order. In last video we have discussed the similar type of questions where we basically constructed a tree using in-order and post-order. In last video what we discussed, in-order and post-order, right? Using post-order and in-order traversal we constructed a binary tree, right? In this video we will discuss in-order and pre-order, right? And I have explained some properties of the pre-order, in-order and post-order traversals in the last video, right? So let's take a quick look at the question. So given a two array representing the in-order and pre-order traversals of a binary tree, and construct the tree and return the root node of the constructed tree. That is what we have to return. We have to return the node of the newly constructed tree, right? And that tree we will construct on the basis of the in-order and the pre-order traversal data. So I hope question is clear. It is very simple question, right? But one of the most asked questions in the interviews, right? So let's take one example here. So here we have the data, in-order data, this is, and we have the pre-order data, pre-order traversal data, correct? So we have to construct this binary tree, right? And we have to return this root of the binary tree, newly constructed binary tree. That is what our question says. So now think about the algorithm solutions. You can relate this question to my last video. If you haven't gone through that video, then please go through and watch that video, right? I hope you know the pre-order, in-order and post-order traversals. If you don't know, please watch my previous videos. There I have explained in multiple videos, multiple times, how can we traverse pre-order, in-order or post-order, right? So the property we will use by in solving this problem is that in pre-order, the first element of the pre-order always would be the root of the tree, right? Why? Because how we traverse using the pre-order? So we draw the line left side, right? Left side we draw the line, and then we start from the top of the tree, right? From here, and see, first time it is crossing the this one, so then we are basically printing the 0. Then second time we go down, the one is getting crossed here, so we are printing 1 in pre-order, right? And then again go down, third this 3 is also getting crossed, so we are printing 3. It means 0, 1 and 3, right? And then nothing is down, so we will go up, 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 nothing is there, we will go down again, and 4 is getting crossed here, so we will print 4, correct? And nothing is down there, so we will go up, no, nothing is there, go up, down, and here 2 is getting crossed, so we will print 2, correct? And then we will go down, down, 5 is getting crossed, so 5 we will print, and nothing is there down, so we will go to up here, back to up, right? Top of the tree again, right? So this is whatever the data we get, this is the pre-order traversal data basically, and that is what is given here, correct? I hope you are clear with it, right? So now when, like, what we can say by seeing this data, the first element of the pre-order traversal data must be a root of the tree, right? And the same thing I said in the last video there, the post order, in post order what we do, we draw the line right side, right? So and this line is getting crossed at the end, right? So in post order what I said, the last element, right, the last element of the post order traversal data is the root, right? That is what we have discussed in the last video, and we have used that, correct? So I hope it is clear. This is very basic property of the pre-order traversal, is that the first element of the pre-order traversal, would always be root of the binary tree, and that is what we are going to use by solving this problem. So let me clear this one first, correct? So I hope you are clear with the question, and you are clear with the property of the pre-order, correct? And in order also, let me quickly explain. So in order what we do, we draw the line downwards, right? So it means when we go here up, right, until here, so this time once this cross, then only we print. It means whatever the left side data will always be the left of the tree, of the root, right? and whatever we see the right data, those will be the right subtree, correct? And it applies for each and every node, right? These properties will apply for each and every node, so that you have to keep in mind, right? So for example, here this one, right here. So for this, if we talk about this subtree, right, then this is the root, and the left subtree is this one, right, and right subtree is this one, right? So in order array, right, so here what is the in order array of this one? 3, 1 and 4, right? And 1 is the root, see, right, 1 is the root. So this is the left subtree and this is the right subtree, complete subtree, this tree. Then this is the root, correct? And if we go here, then what is the in order traversal of this one? This is in order 3, 1, right, 4, 0, 2 and 5. That is the in order traversal of this tree. So and the root is 0, right? This is your root, correct? So now uh, this part is the left subtree and this part is the right subtree, and you can see by seeing this tree graph as well here. 3, 1, 4, 3, 1, 4, this is the left subtree, right? And 2 and 5, this is the right subtree. 2 and 5 is the right subtree, you can see here. So I have explained two properties here. One property from the pre-order, the first element must be a basically root of the tree, and if we see here root is 0, right, root is 0, then this left part will be the left subtree, and right part from that right side from that root index, that would be the right subtree, right? So two properties I have explained, right, one for the inorder and other one for the pre-order. So let's build a algorithm here to solve this problem. So what I will do here, I will get, we know the input data, in order array and the pre-order array, right? So we will return the right root node here, this we have to return. So build tree, I will write build tree, and here I will get in order, I will get pre-order, right, pre-order, and I can get the size, correct? And then what I will do, I will check if so I'm basically writing a recursive approach here, right? So and for recursive algorithms, we must there must be a base condition to break the recursive calls. So that is what I am adding here. So don't worry, I will show you the C++ code for this algo also. So n is 0, right? Then what I will do, I will return null, right? If n is 0, then I will return null. It means that tree is empty, right? And then what I will do, then I will say, I will find the root node value. So we can say val is equals to, and what is the root node value? How can we identify? So we can identify in pre-order easily, because in pre-order the first element must be a root node value, right? So what we can say, the pre of 0, right? The first value of the pre-order traversal would be a root node value, correct? Then what I can do now, I can construct a root node here. I can construct the root node here, right? Root is equals to new node with the this value, correct? Here I have constructed the root node, this 0, correct? Now what I will do, now I will go and recursively build the tree, a left subtree and the right subtree, right? So what can I do now? I can directly say here root arrow left will, and for this I will call again bt build tree, and here I will pass basically for left, right? So now in this array we found this is the root, right? So now we have to consider this part only for the left subtree, right? So what can I do now? I can pass the complete in array, right, in order array. And for pre-order, right, the pre-order is 0, 1, 3, 4, 2, 5. This is the pre-order. So let me write it here again. So what can I do? I can write these array here. This is in order, right? 3 1 3 4 2 and 5, that is the pre-order, correct? So now what can I say? I so we are considering this one, this is the root we calculated only here, a pre of 0, that is the root. Now I will find this in the in order, right? What I will do, I will find this in the in order, so that I can decide what would be the left part, left subtree part, and what is the right subtree part. So for that, what can I say? Index, this would be int, right? Index is equals to, I can write a separate function, right? Helper function, so that will give me the index. So find of I will say here index, sorry, in order array I will pass, and I will pass the value here, right? It will give me the index, correct? And here I have the index. So here in this case, what index I will get? I get this one, and index of this one is 0 1 2 3 4 and 5, right? So 3 I will get here, right? So now I can say, so this part is the left subtree part, and this part is the right subtree part, right? So now I will recursively construct the left part. So root arrow left is equals to binary build tree, and here I will pass the in order traversal completely, right? But here see, here I am passing the complete array, and for pre-order array I will pass pre plus 1, because I have to ignore this one. I will start from here, correct? And here I will pass the size of this tree, sorry, this arrays would be index 1, only, right? IDX. So here I get 3, right? So 1 2 and 3, so it will consider 3 element of from the in order, and it starts from pre plus 1. It means it starts from here, right? And from here it will consider 3 elements. See, these 3 elements only, 1 3 and 4. And you can compare here, from pre-order we are considering 1 3 and 4, and from in order also we are considering 3 1 and 4, right? Because in the in order data, in order traversal data and the pre-order traversal data must be same, right? Each and every node should come in pre-order as well as in the in order, right? That is what we are keeping here, right? 3 1 4, which is coming here, and 1 3 4. It means we can say this is the correct combination, right? Right. Now what we will similarly, we will build the root arrow right? And here bt, here what we will do for right subtree, this is the part of right subtree, correct? I hope you are clear. This, because 0 is our this 3, right? This is our index of the root, so this is the right part, 2 and 5, right? So what we can say now, in plus index plus 1. Why 1? Index, it means 3 elements we have to ignore, and then this root itself also we have to skip, right? So these first 4 elements we have to skip, that is why I am adding here index plus 1, right? So now we are here, and from here we will start, right? Passing this input array, in order array, right? And same we will do for the pre-order plus index plus 1, right? These 3 elements plus this root itself, so 4 elements we have to skip, and here also we will start from this one, right? So 2 and 5 should come at the right side, and same we are considering for in the in order array, correct? I hope it is clear now. And here the size we will pass is, so here we are calculating the index, but this index itself we are using as a size in the root arrow left, correct? For both, but for right, constructing the right subarray, what we have to calculate, n complete array size minus index minus 1, and then we are closing this one, right? So this is what, now this is what is the size here coming, n is here 6, correct? 1 2 3 4 5 6, 6 is the n. 6 minus index, that is 3, right? Index is 3, we got 3, so 6 minus 3 is 3, minus 1 2, right? So this complete now 2, and here also you can see only 2 elements are there at the right subtree. I hope it is clear. And now what we will do, we will just return the root, and we are completing our function here. I hope it is clear. This is very simple algorithm. You just have to go step by step, right, by seeing the input data, correct? So let me explain it again. Here we got 3, 1, 4, 0, 2 and 5, right? This is the in-order traversal data, and here we get the 0, 1, 3, 4, 2, 5. This is the pre-order traversal data, correct? Now if the n is 0, we are passing the size. If n is 0, number of elements in the in-order or pre-order is 0, right? And you it is not mentioned in the question, but it must be there. The size of the in-order traversal data and pre-order traversal data must be same, right? Because we are using the same tree for calculating the in-order and pre-order. So if n is 0, then we are returning null, right? And then we will basically calculate the value of the root node from the pre-order traversal, because the first element of the pre-order would always be a root node value. Then we are constructing the road here node pointer, this root, right? Root node, so new node value, right? So root node got created here, and then we are finding the index of the root node value in the in-order, so that we can basically identify what is the left part and what is the right part. So that is what we are doing here, find index here. So this is a helper function. We can write this. It is very simple, right? From in-order you have to go and find the index of the 0 value, right? So that easily we can do. And then we root arrow left, so we are constructing the root arrow left. We are recursively using, like, passing the in-order pre-order plus 1, because we have to ignore the first element here. That is why we are basically advancing the pointer of the pre-order, right? And then here we are passing the IDX index, right? So this index will be treated as the size of the this tree or in-order or pre-order array, right? That is what, right? So here we are passing complete array, but we are considering only 3 elements, because we are passing the size is 3, right? I hope it is clear to you. And same we are doing for the right side calculation, right? Here in order IDX plus 1. Why? Because the right part starts from the 4th index, right? 2 and 5. So that is why we are ignoring, we have to ignore 4 elements. So that is what we are doing here, index plus 1, right? 4 elements we have to ignore. And same here, right? Root itself and these 3 left subtree part, right? Because first we have to ignore the left subtree part plus root, right? So those we have to ignore, and then after that whatever the data we have, that we can consider for the right subtree, right? I hope it is clear. And recursively we will do this process for each and every node and each and every subtree. I hope it is clear. Let me show you the C++ code for this one. So here you can see this is the function we got, and here we are basically calculating the size n, right? And this is the function call. We are basically passing n also here, and in order dot data and pre-order dot data. It will give the row array from the vector, correct? I hope it is clear. Now coming to our algorithm or main functions, whatever we have added, right? So this is the main function here. So here what we are getting, n, if n is 0, then we are returning null, right? Then we are calculating the value of the root node value, right? Pre-0, because we know the first value of the in-order pre-order must be the root node value, right? So root node value we got here, and we constructed the root node here, right, using the value, right? Now we are finding the index of the root node value in the in-order array, in-order traversal data, right? In-order traversal data here, this one, or you can add a helper function separately, or you can do it here itself, because it is a very simple logic to find the value index, right, in the in-order given array, correct? So now we have the index. It means we can identify what is the left subtree part and what is the right subtree part, correct? And now we can construct the left subtree here. In order we will pass pre plus 1, and index we will pass. So index will be treated as the size of the in order or pre-order array here, right? And similarly we do the index plus input array, so in order array plus index plus 1, right? So in order array, then index IDX we are passing. It means the left subtree part we are skipping, plus the root node itself we are skipping, right? So that is what we are doing here, and same we are doing for with the pre-order array, right? What we are doing here, when we are going to calculate or construct the right subtree, then what we have to do first with the in-order array, we have to skip the in-order part, sorry, left subtree part here, 314 we have to skip, and that root itself also we have to skip. So that idx we are advancing with the idx, right, index value here is for skipping the left subtree part, and plus 1 we are doing to skip the root itself from the right subtree, right, from the in order, correct? I hope it is clear, right? And here also idx we are, this is the index value, right? Index, it means the size of the left subtree. So here 1 3 and 4, 1 3 and 4 are the part of the left subtree, 1 3 and 4, so this we have to skip, correct? And then this 0 itself is a root node, so this is also we have to skip. So these 4 values we have to skip, that is why we are doing this, is advancing to skipping the left subtree, and this is for skipping the root node itself, right? And here then again we are giving the size of the right subtree, and that would be n minus index minus 1, right? I hope it is clear, right? Index is the size of the left subtree, and 1 is the for the root itself, root value itself. So that is why we are right, subtracting from the n, from the complete size of the array, and the remaining part would be the right subtree. That is what we are doing here, right? I hope it is clear. So, and we will do this recursively for each and every node, right? So for example, first here if we dry run this one with this given data, then what we can say, here we will get this data, right? And here 0, we will get this 0, right? So this 0 we will find into this one, so this is the 0 1 2 3 4 and 5, so third index we will get, so here idx we will get is 3, right? Now the left part would be this one 3 1 4, right? And right part would be 2 and 5, right? So right part would be here in order, we will get the left part would be 3 1 and 4, right? This is the in, and pre-order we will get 1 3 and 4, because we are doing the pre plus 1, right? So 1 3 and 4, that is what we will pass to the next function here, correct? And index we already calculated. For right side, what we will do, in plus idx plus 1, so in order, right, from starting plus 3 plus 1, so 2 and 5, right? So for in order, right, so for in order we will 2 and 5, and for pre-order we will pass to we have to ignore 3 plus 1 4 elements, so 1 2 3 4, this is also 2 and 5, that is what we have to do, right? So now we are here. Now again we will go for the left side here, come here, and n is not 0, n is what is the n is 3, index will be treated as a n here this side, right? So 3, so then again we will calculate the pre of 0, so pre of 0, that is 1, right? This is 1, that is why 1 is becoming root here, correct? And index of 1 we will find here, so index of 1 is 0 1, it would be 1, correct? So then this part would be the left subtree, and this part would be the right subtree, that is what 3 is the left, 4 is the right, right? Recursively we are going same things, right? And here then again we will pass the 3 here, right? And from here we will pass the we will skip the 2 element, one size for the left sub part, one is for root, and here we will only right, so we will skip 3 plus 1, 3 plus 1, one part we will skip here, right? So here 3 and 4 we will pass, right? But size is 1 only, so 3 will only get considered here. And now this would be the root for this one, so 3 got here, we have added 3, right? And it would be 0, so size we will pass to 0, right? So here nothing will be, we will return the null from here, right, because size is 0. And same likewise we will do for this one and for this one also, right? I hope hope it is clear to you. What is the time complexity here? Order of n for this part, right? Correct. And order of n for this part, right? And it would be in each and every node we have to go to the inorder array and find the index. So it would be order of n square basically, correct? So we can optimize this one also, because interviewer may ask you to optimize this one, because this time it is taking order of n square. Each and every node we have to go and check the index, and that finding the index is taking the order of n itself, correct? So what we can do, this part we can optimize to order of n to order of 1. How can we do? We can take a basically unordered map. In that unordered map, what we can do, we can give the values, right, in order value and the index itself, right? So for example, 3, 0, 1, 1, 4, 2, 0, 3, 2, 4, and 5, 5, right? So this would be our unordered map, right? We are not basically keeping the order, we are just keeping the key and index as a value, right? So now instead of traversing complete array, if we directly check the 0 index value here, so 0 value index, so that will directly give me 3, right? This one is giving me 3 directly, so I can get the 3 in order of 1 instead of the order of n. So that is what we have to do, right? We can do here. So here I have added one overloaded function here. In that we are getting the unordered map also, and how we are constructing this unordered map here. So see here what I am doing, simply I am just creating filling this unordered map with the inorder value and that value index. That is what I am inserting into the umap unordered map here, correct? Why I am taking an ordered map? Because if I take ordered map, I do not need any there is no requirement of the ordering here. One thing is that. Also the other thing is ordered map, right, takes order of log n to find given value, right? And unordered map gives any value key any value for the key, given key, in order of 1 only. That is why I am taking unordered map here, correct? So here, and then I am passing this umap as a additional argument here, basically, right? This one, and here this is simple line umap of value, so it will give me in order of 1 the index of this value, correct? And now the time complexity of this one is order of n cross order of 1, right? It means order of n only instead of the order of n square. I hope this is clear. This is a similar approach to the last one, whatever we have discussed for the pre-order, constructing a binary tree using the in-order and the post-order. And this is here we are constructing with the help of in-order and pre-order data, correct? So let me know if you have any questions. Comment below the video. I will try to address your problem there itself, or I will cover it in the next upcoming video. Thank you for watching the complete video. See you next time. Till then, keep learning and keep exploring.